let's talk about a problem-solving model. Okay, so this problem-solving model, so let me preface with this. I did not come up with problem-solving models, but I did come up with this one. Well, myself and my students did, to be fair. The birth of this problem-solving model is one out of pure necessity. So I'm going to eventually have a whole course on this and my framework to how I teach complex mathematics in a very easy, basic way, which leads my students to massive amounts of mastery on standards in math. But for this little video today, we are just going to walk through a process of if you were a student and I was a teacher, how this all works. And what's great about this is I'm actually using a full standardized testing question. Depending on what state you're in, you guys know if you're a part of this course that I'm in Texas as of right now. So my students take the STAR exam, the state of Texas assessment of academic readiness, which is a standardized based test that is multiple choice and then 25% tech enhanced. So there's like multi-selects, there's drag and drops, there's gridables, etc. I chose this problem specifically for a handful of reasons because there's a lot of components that go into it. It is a 5th grade standard. The standard is 5.3K. Students will be able to add and subtract positive rational numbers fluently. So I'm going to read the word problem one time all the way through, no pauses, no breaks. Just a reminder, my environment that I teach in, my area of expertise is Title I, bilingual, English as a second language, low socioeconomic status. So you have to remember that I am mainly teaching kids below grade level. As a math specialist and an interventionist, I go push in or pull out students that are far below grade level. So if this feels a little bit slow to you, you can still implement these strategies. You can still implement these tools. You might just move a little bit faster than I'm moving today. So here we go. First time all the way through. Miss Fitzgerald had 2 1/4 gallons of fruit punch. She served 3/8 gallons of fruit punch to her family at lunch. How many gallons of fruit punch did Miss Fitzgerald have after lunch? So we read it one time all the way through, and then I ask my kiddos to give me a little check mark to show that they read the problem all the way through without stopping. Okay, y'all can see my laundry back there. Like, listen, I would pretend like I cared, but I do not. I am a mom, I am a teacher, I am a coach, I am busy. Yes, I have laundry piled. You can have thoughts about it if you want. It's okay. You may judge me. I take full responsibility. Okay, let me keep going. So we read it one time through. Now I ask them to pause. And we're going to use a process that I like to call chunk and juice, especially with our English as a second language kiddos. There's translating still happening in the brain here. So by pausing at punctuation, periods, commas, question marks, exclamation points, and reflecting on what it is that the question is actually asking is very, very helpful. I do this as kind of a cold call or a choral response, oral response. I don't necessarily, especially in test prep, I don't let myself just do all of the talking. I really like to engage my students at all times. And I also am lapping the room during these question exploration stems, which you're going to hear, which you are going to hear in a second. And I also like to do this document camera style, so they see my paper just like I want their interactive journal to look as well. Okay, so we're going to read the sentence again, and this time I'm going to clap at the punctuation. I want you to follow along with me. Miss Fitzgerald had 2 1/4 gallons of fruit punch. What's juicy there? And I call it juicy because I say we got to squeeze the juice out. I make them hold an invisible orange and squeeze it. I don't want the rind. I don't want the pulp. I just want the juice. I want you to squeeze that orange so tight that just the juice comes out. Because a lot of times kids just like to restate the statement or the question. I don't need that. I just need the juice of it. So she had 2 1/4. This is important. I dig for work, important information. Then synergistically, especially in 5th grade, I like for them to use these two or these two fluidly, meaning we're not quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. I want them to be able to synergistically move throughout these two quadrants, because this is going to help their brain make the connections of what operation needs to happen here, okay? So then we talk about, okay, I had 2 1/4. What does that mean? What does it mean to had something? And then you'll get one brave little kiddo that says, well, had, and then they'll start putting 2 and 2 together. Man, I had lunch at 12. I had 4 pencils on my table. Now I have 0. I had a bad attitude yesterday. And then they'll start to make the connection. Oh, had is you no longer have it. Exactly correct. So we go down to the flow chart, making that line. Had means I no longer have it. Great. Now we move on. She served 3/8 gallons of fruit punch to her family at lunch. Okay, what did you see there? She served 3/8 gallons at lunch. Again, what does serve mean? Then you'll get the kiddos, oh, mom served me enchiladas last night. Mom served me juice. Mom served me, dad served me, a sandwich. Grandma served me spaghetti. Like, you start to really make connections with what they hear this vocabulary all the time, but sometimes when it's in a mathematical problem, their brain just takes over and they get extremely overwhelmed. This helps simplify that process. Well, serve means that she gave them something. Okay, awesome. So we're going to say served means that she gave her family punch. And then if it's a bilingual classroom, I might even talk about what is fruit punch. We sometimes overlook those things as adults because our vocabulary is so vast, but we have to put ourselves in the student's shoes. If I'm an emergent bilingual student and I've only been in the country for 2 years and I see fruit punch, I might not know that that's an actual drink of water. And so sometimes what I like to do is, if those little details are messing with them, I like to just cross that out and just replace it with water or juice or something that they know, but I'm making that connection and taking the drama out of the problem. Okay. How many gallons of fruit punch did Miss Fitzgerald have after lunch? Okay, so we're looking for how many gallons after lunch. How many after lunch? Okay, then I'm going to ask my kiddos, what's the main idea of my text? I pull cross-curricular in here. I pull their reading. What is the main idea? Let's infer. A lot of times kids like to restate the entire question here. A lot of times our students are going to repeat sentences that you have written here. But what we're actually trying to get at is helping them make an operational choice. So what is the main idea of my story? Miss Fitzgerald, she had 2 1/4 gallons of fruit punch. Then she served 3/8. How many gallons does she have left after lunch? Okay. After lunch. So the main idea of this text is fruit punch after lunch. Okay. Do we know how much she started with? Yes. So we have a total. If we have a total, we are doing one of 2 operations. If we have a total, we are looking to either partition that total, or we are looking to have the total and we're looking for the part that is missing. What 2 operations break something down, decompose, partition? Those 2 operations are division or subtraction. Then I go a step further. Do you see grouping language in this story? Let me move my board back a smidge. Grouping language. Grouping language is things like each, every, per, same amount, split evenly, partition, right? Is there any evidence of grouping language, same amounts, equal cuts in our text? No, there's not. So if we are not grouping, we are doing the non-grouping operations, which are subtract or add. Because our grouping operations are division and multiplication. So this helps our students decide what operation we are doing here. So if your babies are having operational confusion, having them go, what is the main idea? Do I know how much I have? Do I see evidence of grouping? Do I see any evidence that she served me and my sister the same amount of punch? No, that's not evident here. So what operation appears most often? Subtraction. There's 2 votes for subtraction. So now I know that I am subtracting. So if your kiddos are having that trouble, taking them through that flow chart is really helpful. For the draw section, you are going to have this one of 2 ways. If you're a lower primary teacher, you can actually draw this out. She had 2 1/4. Then she gave 3/8, right? How much does she have left? For upper elementary, I like to push their thinking a little bit and have them start to build out an equation. What's my total, right? What am I'm looking for? How much she had after lunch. So I'm going to write P for punch. She starts with 2 1/4. That's how much she had. Then she went and served 3/8. We know it's subtraction because of our flow chart. There it is. And now it's time to do the workflow. Now, I am going to go through how to solve this problem just because I feel like if I didn't, it would feel a little bit empty, right? But in the workflow, you want to see all of their mathematics happen right here. So for subtracting mixed numbers with different denominators, there's a lot that goes into this. This is not necessarily something that I would kick off a lesson with. This is more of a demonstration of learning. I mean, this question is right from our standardized exam, so it doesn't get much tougher than this when it comes to what is the student actually supposed to know by the end. So I start with my total. Then I subtract one of my parts. And out should come the other portion of this. I notice that my denominators are different, which means I can't touch this. You better believe I play MC Hammer when I teach that teak, okay? We can't touch this. We can't touch them until they're apples and apples. Right now, this is an orange and this is an apple, and I want them to be the same fruit. Well, what do I know about the number 4 and about the number 8? Well, if I keep skip counting by 4s, I eventually run into 8. And when I teach this teak, I have them make a little T-chart. 4, the next multiple is 8. Oh, that's my lowest common denominator. Okay, so we make a new fraction with our LCD. And I ask myself, how do I get from 4 to 8 using multiplication? Well, you multiply by 2, Miss Silvio. Absolutely. Whatever I do to the bottom, I do to the top. And I have them kinesthetically do that times 2. I could stop here. I could make this enough, but it's worth going that extra mile. What do you notice about 1/4 and 2/8? Well, you just doubled it. I sure did, didn't I? I wonder what fraction is bigger? A lot of kids will say 2/8. And then you get to teach on, actually, they're the same. And I go one step further than that. I've been teaching at the same school for so long. They've seen me pregnant. They've seen me have kids. They see me all the things. I say, guys, this is skinny Miss Silvio. This is Miss Silvio when she's working out, when she's feeling good, when she's, all the things. This Miss Silvio after she's eaten too many pizzas. And I just, you know what I mean? You got to make it fun, y'all. Like, I mean, all jokes aside, like, we're not trying to, I'm a fitness coach also. So like, this is not about like, oh, like that. You just have to, sometimes we have to go weird for the kids to get it. We have to go weird for the kids to get it. But I am a body positive person. So I do like to be like, this is Miss Silvio, no babies, right? This is Miss Silvio when she's having a baby. I had a very large son. So he was almost 11 pounds. So when my kids saw, like, I would hit my kids in the back of the head with my belly when I was walking through the aisleway. They all know this, right? So I talk about that. Like, this is Miss Silvio, no baby. This is Miss Silvio. Remember last year in April? And they were like, yeah, man, you were hitting the back of my head, Miss Silvio. And I'm like, I know I was hitting the back of your head. And then I like to go one step further than that and just showing them that they're actually multiplying by just 1. Because 2 2s, 2 halves is actually equivalent to 1. So you're multiplying by 1, just looks a little different. That's all. And that's where I talk about pregnant Miss Silvio, non-pregnant Miss Silvio. I'm still me. I'm still holding you to high expectations, loving you, teaching you how to deep breathe, taking care of your body, taking care of your mind, and taking care of your emotions. But I might look different, but I'm still me. Okay, tangent over. Then I like to have them cross that out because it no longer serves them. Then we notice, oh, there's already an 8 here. We have apples and apples. We are good. Good to go. Now we circle our numerator. 2 minus 3. Hold 2 fingers up. Remove 3. I can't. I'll go into negatives. Exactly. And you are a 5th grader right now, which means we don't go into negative integers until 6th grade. So what can we do? I wonder what we can do. What would you tell a 2nd grader to do? Well, I would tell them to regroup. Exactly right. So let's regroup. Let's pull. 1, now we're in regrouping land. And most of them will say, give it 10. Why do we give it 10? Then we go and we get to explore why giving it 10 is actually not relevant here. And I'm going to show you why. Did you know you were getting a math lesson today too? Let's say I've got 10 minus 7. 0 minus 7. You can't do it, Miss Silvio. I know, baby. So we pull from the tens place and give that a bundle of 10. Now, the reason why we give this ones place 10 is because we're pulling from the tens place. This is pulling from the ones place, the ones. So what is 1 whole as a fraction with a denominator of 8? How many 8s equals 1 whole? 8 8s. You can see how I'm pulling in this knowledge to apply it with this knowledge here. We're going to give the numerator 8 because 8 8s is equivalent to 1 whole, and you're pulling from the ones place. Now 2 plus 8 is 10. We've got an improper fraction, but we don't make that mean anything about us. This is not a problem because we're about to change it anyways. 10 minus 3, 7. Denominator stays the same. 1 minus nothing is 1. The amount of punch that Miss Fitzgerald has left after lunch is 1 7/8 gallons. And if you were a student, I would have you write that whole answer sentence right here. So there it is, y'all. There it is. There it is. We are going to be talking more about this. In my 12 years of experience, this has been a game changer when it comes to my students solving problems with mastery.